Hello everyone, welcome to today's educational video on solid principles in Java programming. Specifically in Java programming because I belong from Java background and as you all know in any software designing or software development project where we create the software from the beginning, it is very important to follow certain sets of principles which which makes the code and hence make the code easy to maintain and it makes it easy to enhance in terms of new feature releases. So in this today's video we will discussing the third principle of the solid principle. In the previous two videos we discussed about uh, first principle, which is single responsibility SRP, and then we discussed open close principle, and the third one will be the list scope substitution principle. L in the solid stands for Liskov substitution principle, or in shorthand we call it as an LSP. This principle states that the object of the superclass should be replaceable with object of a subclass without affecting the correctness of the program. So following the LSP ensures that the subclass adheres to the same contract as their parent class, and this enables us to use polymorphism effectively and create code that's more reliable and predictable. Now when we talk about polymorphism, here comes the concept of inheritance. So whenever there is a simple, we use subclass or a child class objects to substitute the values of the parent class, and that should not be alter the desired property of the program. That's what the list of substitution principle ensures, that whenever a subclass or a child class object is extending to its parent class, the subclass or the subproperty should not be altered. It should not alter the property of the parent object class. In terms of there are two substitutions done: simple type based substitution, that is in context of Java, and also there is a behavioral subtyping. And the base class of the object in terms of behavioral should not change the behavior also. If the behavior gets altered, then this is a violation of Liskov substitution principle, and this ensures that the subclass adheres to the same contract. This enables to use polymorphism effectively. That is why it becomes important to follow this cross substitution principle. We will understand it much better with a hands-on project. So we'll move on to our IntelliJ IDE. We discussed two principles last time. Here I'll create a new package for LSP, Liskov principal substitution. And if you look up for any coding interview questions for solid principle, you will mostly find an example of a rectangle and a square object. So we will discuss now what does this code basically mean when it comes to inheriting any parent class object. So in this case, I have a rectangle class with two properties, a length and a height and a breadth, and it has a constructor and some getters and setters. So this is the basic rectangle class. When it comes to square, you see this code, particularly square extends rectangle, and then it has a constructor which implements a super constructor of the parent class, and then it overrides the set and the set within the side set height method of the rectangle class which it is extending to, and then it has an additional set side method. As you know, square has both all four sides equals, so the length is equals to width. So this set method basically sets the width and height similar to the side that is passed, and we call the set side method in each setter method of the overridden rectangle class. So this basically is running. We'll see what the error is. Basically this program will check, and in the main class we're creating two objects, on rectangle and a square, and there is a use rectangle method, static void method, which will pass in rectangle object. So as you know, square is extending the parent rectangle class, so we can pass in the square due to the polymorphism that is available in the Java programming language, and that will be using the set side and set width method. So here if you see, the rectangle is perfectly fine, it sets the height to 20 and 30, and then we are using the assertions to check if the set value and the height value, the width value is correct or not, or else it will say it is not equals to 20. So we're using the assert operation. So now we'll just test it without, right now the code is in a violation. So we'll modify the run configuration as we are using the assert plus we will have to mention the VM arguments, which we can set it by modify environment variable. So we will run this program. Before we run the program, we need to, because we are using the assert library, we'll need to modify the run configuration under modify option, add VM options. We'll have to add modify options, VM options. I have to set this to EA so that it can use asset operation. Now when I run this program, you can see uh, whenever the square object is passed, it will try to set the height to 20 and the set side method will set it to 20 and 20 both the side, but the assertion will fail because the height is not equals to 20 because that width will again set it to 20. So basically if you can see the extension of rectangle will override the attribute or the property from the rectangle class in the square, and basically this is the violation of Lisp principle, which indicates or which instructs the developer that we should not alter the attribute property of the extending parent class. And this is the reason that this core principle needs to be followed. In many interview questions that you may be appearing, if they try to explain, you ask you to explain the this core interview, this core principle, then this is the common example given where a rectangle and the square is. So to retrofit this code, we should use uh, interface instead of inheritance, and basically we can create an interface called shape, and which will then be having an implement contract of creating the compute area. So you can give public int compute area, then we can modify, we can break. So in order to fix this issue, the not allowing the attributes of the parent class to change, we need to break this correlation between rect square and rectangle. This can be done by implementing the shape. This is just an implementation of shape where it will just contract out the information, and here this will be this dot side equals to side, and we need to define a property called side private inside the square. The sides are similar, and now we don't need to use the setter getter override methods from the rectangle class because we have broken the relationship between, as it was in violation because of Liskov principle. And then the set side will be written set the side this dot side equals to side. Then we will implement the compute area method. So implement the method compute area method from the contract that we just implemented, and then this will return this dot side side into this dot side. This is how it will compute the area. Again in the rectangle we can utilize again the same shape contract interface, and then this should be overridden, or you can say override. Yeah, right. So with this, if we check now, the issue should not come. The issue is resolved with this. So the relation that we were having between a square and so yes, there is another issue. We need to create a square object, and this now should use a different class, or you can say rectangle, in terms of should not, you cannot pass the same rectangle. So you use square, pass in square object, square that we just defined, and here it will be use square, and there is no need for anything like rectangle set height or method because we have broken the square set side to let's see, 20, and then this will be square dot get height. We haven't defined the get method yet. We will mention this public int get side. We should return this dot side. Now with this we can get the side method, check if this is equals to, and here we will say side not equals to, sorry, to side not equals to 0 in case if it is, or 20 in case of it we pass it. Now with this we can simply run the program and it should run without the failing. So basically what we did is we knew square was extending to rectangle class. So rectangle setter methods were being override in the square methods, which we were altering those final functionality provided by rectangle. So this is what the Liskov principle suggests, that we should not any subclass or any adheres subclass which inherits to the parent class should adhere to the same contract as their parent class. It enables to use polymorphism effectively, and in case if it does not adhere to the same contract and alters that principle, then it means that we are violating Liskov principle and that code is not correct. It's not based on the solid principles described, and that's how we fix the error. And we are done for the Liskov principle for now. The following video will be discussing about the fourth one. Starts with the letter I, which is called interface segregation principle. So the following video will discuss on the fourth principle, and then the last one is dependency inversion, which is a very interesting one. So thanks for watching the video, and see you soon in the next video. Goodbye, take care.